Hello and welcome to Antimatter Skunkworks. So when I set out to make an automated candy dispenser, I naturally went to YouTube and looked around for designs that already existed. And I didn't choose to do those because what I found was, with the exception of one that I'll mention later, all of them only did candies of sort of a regular size. The same size or a small size, or they were all very tightly wrapped or something. And one of them was even like raw gumballs, and I thought kids wouldn't want to necessarily put a raw gumball in the bag with their wrapped candies, right? So I needed something that could handle a wide variety of candy, the kind of candies that I like, including bags. And bags are kind of problematic because they move around so much, and the corners can get caught under things and stuff. So none of the designs handle those, and so that's why I kind of came up with my own. Yeah, just wanted to explain that before the video started. Alright, to shorten up this video, I'm just going to show some background of how I was building it to begin with. I'm not going to show you those steps because what happened was I originally intended to build this dispenser as a joke where I use a useless box. If you don't know what a useless box is, it's you throw the switch and a little finger comes out and turns the switch back off again, and I'll explain it here in the video, and probably a couple more times, in fact. So I didn't really care. As long as it looked like a dispenser, I didn't really care, and I wanted something simple, which is why I took that 2 foot by 2 foot piece of steel and just sort of bent it into the shape that kind of resembled the dispenser. But what happened was the idea kind of backfired because I created a window that you could see the candy inside, but throwing the switch didn't make candy come out, and people didn't understand it. And they didn't know they were supposed to ring the doorbell then. They just thought it was broken, and he kept trying to throw the switch and stuff. So I decided to make an actual candy dispenser, but I wanted to use what I'd already built. And the reason this is important is because if I were to do this all over again, I would do it differently. I would make the candy dispenser much wider so that my screw was much longer and could drop the candy in the middle of the screw where it wouldn't get bound up on the ends or anything. I didn't have much room for that because my dispenser wasn't wide enough. So that's where all this came from, and you can see here how I started and what it looked like. The doors and things on it weren't really supposed to work. So later when I made them work, I had to do a bunch of extra design and fabricating and stuff. So in the end, it kind of came out looking like this. The big square in the middle was where the window for the candy was, and then the door was beneath that. And the dispenser thingy tray at the very bottom there obviously didn't work, didn't go anywhere. So that's kind of what I had to work with. So to make my helix, what I did was I marked out the helical shape on this tube, which is smaller than that one because I'm going to have a little spring out. I hope it's not. I'd rather this be a little bit smaller, but we'll see what happens. And how you do that is you figure out the distance you want it apart, and I'm guesstimating 2.75 because this spring was about I think it was 1.5, and it wasn't enough. Double seemed like too much. So what I did was I marked a starting point here, and then I went down, say here, 2.75 inches, and I marked and I marked and I marked, and then I rotated a quarter, and I divided 2.75 by a quarter and went down that far, and I started there and did 2.75, 2.75. Then I did a half, and I did 3/4, and then that should bring you back to the second mark on the original side. So here's something I didn't really think about, and that is the handedness of the screw. So I put some candy, not in a trough, just on the table, and I just turned this. And it didn't seem to be working, and then I realized that, oh, well, what if I turn it the other direction? And it seemed to transport the candy along a little bit, so it's looking promising. However, I had to turn this in the opposite direction of my motor. And that brings me to the handedness of the helix that you wind. I've made mine this way, and I could have, and in this case, I guess I should have made it go that way. So it's basically a left-handed screw versus a right-handed screw, right? If I can reverse my motor, it wouldn't make a difference, but I only have one motor that works both directions. The other two And I don't know why. It seems like all you should do is reverse the polarity and you're good to go. But maybe it's something with the gearbox. I don't know. But it's got a plus and minus marked. So I'll check and see if that's a big deal or not. The other thing is, now I just need to make sure there's enough room over this distance to, do what I want to do. It can be difficult to visualize, so I went and put the candy in and I turned and saw which way it moved and which way I would rotate, and from this end I would turn counterclockwise, so if I put the motor on this end I would turn clockwise. So all I have to do is reverse the end on which my motor mounts, which is funny because it's kind of hard to figure that out. You think that it's a right-hand screw, it's a right-hand screw no matter which way you put it, but yeah, indeed it will work that way. And I'm thinking this is actually going to work. That candy, just rolling it on the table like this, the candy seemed to just move right along kind of nicely. So I'm thinking once I put it in this tube, which as you can see it fits nicely, I think it's going to work really well. So now I'm going to cut a hole for the candy to go into, and then the spring goes inside and the candy will fall in, then push down, and then fall out the other side, right? Alright, so here it is, but you'll notice when I try and turn, the whole thing goes together. It's kind of binding here, and it didn't bind before. It slid in and out really nicely, and I think what's happened is there's some built-up stress in this tube, and when I cut it, that relieved the stress, and it actually wanted to pull in, not spring out, so that's trapping this. Since this spring is sort of misshapen to begin with, and it's difficult to keep it in a helix form, what I did instead was I heated up right along here on the inside and the outside with the heat gun and just pulled it apart. You can actually see it goes a little bit straight here now. I mean, I only needed a little tiny bit. I just pushed these two apart just a tiniest little bit and held it there for a bit while it cooled, and then I think it came out just fine. It doesn't have to be perfectly circular, right? Just got to fit this in there. And you can see this spins nice and easily now, very little friction. This is how it works. As the screw turns, you can see it transports the candy in that direction. And nothing jams up at all. We need a little refining. Okay, I think I discovered the fix. This end can be flat because it's always pushing the candy away, this end. But this end needs to keep tapering so that it doesn't get jammed where the coils come together. So in this new method, you can see the candy just keeps moving off the end. Alright, it took some bending and moving, and I heated the tube up again to expand a little till I finally got it to be, I think, a little bit smooth. Let's see. So if I hold the motor still, you can see it strains a little bit in areas, but the current doesn't go up, and if I angled it, so it's got a little bit of drag to it. So I was trying the candy out, and you can see a few issues. One is this, it can get stuck up there, so I'm going to need to maybe make something to keep it from doing that, but more importantly, you can see the M&Ms got jammed up in there. So I think I'm going to cut the rest of this away and see what happens. Alright, so I added this little piece here to help direct the candy in, and it also kind of keeps this from rotating, so that's pretty good. I also intend to cover up this whole thing with a real slippery tape so that none of the candy can get stuck in these little gaps and stuff. When I was looking up methods to deliver things that were like candy, I found basically two methods. One was this screw method that I've come up with here, and the other was a conveyor belt. For various reasons, I didn't like the conveyor belt, and I decided to go with this method. However, today I discovered a third one, which was a turntable, and then there was an arm mounted over the turntable, And as the candy turned around on the turntable, it hit the arm and slowly, because it was at an angle, slide toward the outside and then fall off. That would have been much simpler, and now I wish I had chosen that design, but I'm so far along with this one, I think I'm just going to keep going with this. I will put a link in the description to that guy's device. Now, it was also for delivering Halloween candy, but he had a lot of other things I didn't like about his design. I mean, he kind of overdid it, in my opinion. He 3D printed every single thing, and he took a off-the-shelf part for Halloween, and it took like 25 seconds to run through its cycle. So I can imagine 4 or 5 kids coming up together, they're not going to want to wait 25 seconds for the next piece of candy to drop, right? So, but it was still a good idea, and it could be refined. Now, this one I will show you is functioning more or less properly. It will jam. It jams every now and then, and I will make a method to warn me of such a thing, and I have yet to do that. Here's the current draw with no candy. It's just about 100 milliamps. Now, when you put the candy in, it will rise significantly to about 120 milliamps. And what I found is when candy gets wrapped around there and jammed into place, the current climbs to about 240 milliamps. So I think I'm going to set a limit of 240 milliamps. If it hits that, the machine will shut off and assume it's got a jam. And I think I'll give myself like a warning light to tell me that that's the case. The warning light will also be there to tell me if the candy is run out, and I'll have to come back out. Alright, I've got 2 cameras, one on this side and one on the other side. My old one over there may be blurry. And the idea is to check and see if this is working now. I got the motor all hooked up, and I'm actually right now testing this sort of chute design to see if everything jams up or something. Here we go. I can see the M&Ms getting like completely molested in there. Okay, that worked beautifully. I think this is okay, but I did discover something, so I'm glad I did this little test. The idea was to take this chute and have it spring-loaded so that it was up, and when a candy dropped on it, it would push down and trigger a switch saying, hey, a piece of candy dropped, you can stop now. The problem with that is on the other end over here, some of the candy stayed on the chute. That would turn it off and leave it off, even though it needs to dump more. Well, theoretically not, though, right? Because if there's candy there, somebody could just take it. Okay, I'm at the point now where I'm going to put it all together. I tested the microprocessor board, which is there, and unfortunately I put on a separate board the relay for the motor, as well as a resettable fuse and a regular fuse. Probably redundant, but I'm not really sure if that's going to work. I'll find out. I'm thinking about testing if I just grab a hold of the motor when it's running and see if I can get it to stop via the resettable fuse, and then see if it restarts again on its own. Or I'll just trust it. I don't know. Anyway, I'm putting it all together, and this thing goes in here. I'm thinking down here. That'll allow the 2 sensors to reach the bottom up under here. And I'll have to make the sensor that triggers the whole thing. I think it's going to come out under the motor here somewhere. I think I'm going to have people wave their hands underneath the thing. For COVID, that means they don't actually have to touch the unit. But also, if it's pointed down, I think it'll be shielded more from light coming in. That might affect how the sensor works. And I already have something bulging out to the side here, so I'll probably make a box that goes around here. I'll connectorize these, and I'll figure out a way to mount them. And then I'd also like to take apart a lot of this stuff and paint it. I got some orange paint over here, as well as I've got some black, and I'll figure out some kind of Halloweeny themey, and then put it all back together. So I have a little visitor here. I don't know if you can see him. Right on the edge of the curb. I'll get closer until he leaves. Maybe I can just zoom. There he is. Hey, buddy. Just getting some sun.
Alright, so I took basically everything apart so that I could weld on it in a few places and clean it up and get it ready for paint. I've sort of sanded the outside. Now I gotta put some alcohol in it or something. Gotta still do a little on the inside because I want to paint the inside too. Mostly just for rust. I did, however, buy a bunch of orange paint, and I'll show you that. So my wife got me this. It's Rust-Oleum. I haven't had a lot of luck with Rust-Oleum. And in this case, it's a different kind of luck. It fell on the ground. Actually, it was a horrible incident. I was drilling this hole. The bit caught it and flipped the entire machine onto the floor, and it knocked the paint thing off too. And it not only broke the cap, it was on, but it broke the spray nozzle and sort of bent it. I've tried it. It still sprays, but I have a feeling over time the paint's probably going to come through there and all over my finger. I have another can of paint. I might be able to swap the buttons on, and we'll see what happens. So I'm going to basically try and use up maybe the whole thing on this because it's just going to be wasted otherwise. Well, there it is. That's seriously orange. I think it said something like True Orange on the package. So that's just the first coat, and obviously I didn't do the inside yet, which I need to do just to protect from rust. I think the inside would be better black. So it's been threatening, but it hasn't rained in 3 days. That's because I wasn't painting in the last 3 days. But literally the minute I put paint on it, it starts raining. There's little drops. I think I'm just going to let them evaporate. I really don't care. It's just Halloween decorations. I mean, I've got runs, and I've got grinder marks, and who knows what else on here, right? So I'm just going to go inside and do some work. Alright, so there it is with most of the paint finished. I still have to put there's a little door in the bottom left there that goes on, and then I need to label it Trick and Treat, and that kind of thing. Also, got to put it back together. I did put the window in, which has a nice scratch on it, since of my catastrophic incident with the drill. So this is the point in the video where disaster struck. This is a long explanation, so I'll try and make it quick. But basically what happened is I consider myself the world's second worst software programmer. And so what I did was, long before I ever did any of this other stuff, I got the software working. It's just a very short program and fairly simple. But on my desk I used LEDs to indicate the things that I wanted to control. So if I wanted to turn the motor on, my LED would light up and let me know, hey, I turned the motor on. But when I put it all together, that's not what happened. And I therefore assumed that I was doing something wrong in my software, because I'm so bad at it. And as it turns out, I wasn't as bad as I thought, I guess. I went on to the forums to try and figure out what was going on. Oh, and FYI, the problems were that it was just randomly acting up. Sometimes it wouldn't run at all, or run for 2 seconds or something. Other times it would run just fine, but when I would try and turn it off, it wouldn't go off, and just really random. Sometimes it would run and run and run. I had to unplug it to get it to shut off, and so on and so forth. So chaos, dogs and cats living together. So I went onto these forums, and Arduino forums, and I asked programmers, hey, what's wrong with my software, which was not a pleasant experience. I don't recommend it. You can get some answers there, and you can find some really nice, helpful people. They know what they're talking about, which they'll be happy to tell you they know what they're talking about in a very condescending and pedantic tone. So, yeah, go there as a last resort. But anyway, in the end, we finally got down to they helped me get to the point which I think was a motor problem. And to explain what the problem was, let me explain a little bit about how motors work. So, very basic, so please don't complain. If you put voltage on a motor, it will turn. If you turn a motor, it'll generate voltage. It can be used sort of in either direction, which is why a generator is nothing more than a motor sort of used backwards. There are many, many kinds of motors, by the way. You can't do this on all of them, but I'm using a very simple DC motor. What happens, though, is if you turn the motor and you generate this voltage across the terminals, you'll get that regardless of what's going on. So if you apply voltage to the terminals, and that causes the motor to turn. Well, the motor's turning, so it's going to put voltage onto the terminals. This is called back EMF. This back EMF has a tendency to essentially lower the voltage that's needed to run the motor. Could be kind of a good thing. In my case, however, it was a bad thing because this back EMF was getting into my circuit and causing the microprocessor to basically lose its brain. And either it couldn't count, or if it counted properly, it couldn't turn on or off what it was counting for, and so on. And so I tried various things. At first, because I thought it was code, I actually rewrote the code fully, not just trying all different kinds of little pieces of code here and there that people were helping me with, but literally fully wrote 3 different ones that all worked fine on my desktop. And I'm now convinced they all actually worked just fine. But I got some parts, and this is why it extended beyond Halloween. One's called an opto-isolator, and it's supposed to isolate the motor from the circuit, and I was really surprised to find that it didn't, or at least not in my case, not enough. The only thing that worked in the end was I had to buy a different motor. In fact, I bought like 3 of them off of eBay. They weren't super expensive, but just kind of annoying because the motor I wound up with in the end, and I think I allude to it in the video, it's a little slower than the motor I was working with, and I like the speed of the motor I was working with better. But one of them didn't have this back EMF problem, or at least not significant enough to affect the microprocessor, and everything started working again. So, if you have that problem, you might consider that as a cause. How to order the right motor, I don't know. I can only tell you the one that I bought, which may or may not help because, I mean, on eBay, you don't know what you're going to get, right? So you might just be prepared for that because 2 of the motors I still have laying around had the problem and one of them didn't. And I don't know enough about the details of the motor to know what causes one to be okay and one causes it to not be okay. So anyway, yeah, that's what happened. Thanks for listening. Okay, I'm getting very close to being finished now. All the electronics are in place. I gotta sort out the wiring a little bit here, but I'm doing that now. I put the 2 sensors on here. They were close enough to mount without having to connectorize them. However, this chute goes down, and I would have had to try. I couldn't get a screwdriver up, underneath there, so I wound up having to put them on now and then connectorize on this end and then snap them together, and it's probably better that way. It'll be easier to change one out if there's an issue. I made sure that they're the same, so it doesn't really matter which one plugs into where. So this is the new motor that arrived. It's supposed to be a 6 RPM motor, but it's only 5.5 when I measured it, and it does seem a little bit slow because my other 6 was like a 7.5. So there's 2 RPM difference. It's kind of slow, but I mean, seems to be working okay. And I've already tested it with the microprocessor, and it didn't really cause any issues. So I think this may be the way to go. So I'm just measuring the current now. It looks like it goes from 75 to, I saw a high of 95. Let me see what happens when I put some candy in it. So we still have some leftover candy and grinder here from Halloween. I'll just dump that in here and see what happens. Okay, at this point I will leave my circuit on the screen for you. You can pause it and maybe take a screenshot so you can see what I did there. Never mind the transistor in the bottom right corner there that's just extra sitting there. I've labeled pretty much all the parts I used unless they're generic. Of course the DC motor is generic, and so is the voltage regulator. So anyway, if you have any questions, my channel is small enough where if you ask, I'll probably answer, at least eventually. You can put it in the comments, or you can send me an email at Antimatter Skunkworks at gmail.com. And I will put the code in the description. I'll just leave you here with the machine properly functioning and ready for Halloween 2021.